last skill that we're looking at in probability is the use of tree diagrams. So we're going to look at two examples. So let's take a look at the first one. The probability that John is late on any given day is 1 out of 5. Find the probability that John arrives on time 2 days in a row. So what we're going to do is we're going to draw a tree diagram. So I'm going to do day 1 here and day 2 here. On day 1 he can either be late or not late. On day 2 he can either be late or not late. Late or not late. We're then going to put a probability on each branch. So the probability that John is late is 1 out of 5. So here, that's 1 out of 5. So I know the probability of him not being late must be 1 take away 1 out of 5, which is 4 out of 5. And I can put the same probability on each of the branches. The probabilities don't change in this example. So there's 4 outcomes that I end up with. Here, it's the probability of late. So he's late on day 1, late on day 2. What I'm going to do, I'm going to multiply together my probabilities to get me that outcome. 1 out of 5 times 1 out of 5. Remember, we multiply the numerators, multiply the denominators, gives me 1 out of 25. Probability of late on day 1, followed by not late, is 1 out of 5 times 4 out of 5, which is 4 out of 25. The probability that he's not late, followed by late, is 4 out of 5 times 1 out of 5, which gives me 4 out of 25. And the last one, the probability that he's not late and then not late again, is 4 out of 5 times 4 out of 5, which gives me a total of 16 out of 25. Notice that if you add those up, 1 plus 4 is 5, plus 4 is 9, plus 16 is 25, would give you 25 out of 25, or 1 whole. So the probability that he arrives on time 2 days in a row, well, which of these is on time 2 days in a row? It's just this one. So probability on time 2 days in a row equals 16 out of 25. Notice it could ask a slightly more difficult question of saying, what's the probability of being late once and on time the other time? Here you'd have 2 outcomes, you'd have this one, and you need to add them together. Okay, but the answer to the question is 16 out of 25. Just pause the video now while you take that down before we go on to the second example. So looking to the second example, it's slightly more complicated because the probabilities change. Because what's going to happen is I take one of the sweets out of the box, I eat it, and then I take another sweet. So depending on what I've taken, the numbers left in the box are going to be different. So we're going to start at the beginning with 3 caramel and 2 nut. So I could take a caramel or I could take a nut. There's 3 caramels out of 5 in total, so it's 3 out of 5. There's 2 nuts out of 5 in total, so it's 2 out of 5. Now, if I take a caramel, then my number of caramels gets reduced by 1, so I'm only left now with 2 caramels. I haven't changed the number of nut sweets in there, I didn't take a nut, so it's 2 caramels and 2 nuts left. So here, the probability of taking another caramel is now going to be 2 caramel out of 4 in total. The probability of taking a nut, I've got 2 nuts out of 4 in total. Now let's look at the other branch. I started with 3 caramels and 2 nuts, I took a nut, so I'm left with 3 caramels and 1 nut. So probability of taking a caramel is now going to be 3 out of 4, and the probability of taking a nut is going to be 1 out of 4. It wants the probability that they're both the same. So either caramel, so let's take a look. Probability of caramel up here. Probability of caramel is going to be 3/5 times 2/4. 3 times 2 is 6, 5 times 4 is 20, so that's 6 out of 20. That's the probability of caramel. Probability of nut is going to be 2 out of 5 times 1 out of 4, which is 2 out of 20. So I could either get here to have both the same, both of them are caramel, or here for them both to be the same, both of them to be nut. So I add them together. Probability both the same is 6 out of 20 plus 2 out of 20, which is 8 out of 20. And I don't need to simplify that. That's absolutely fine to keep that just as 8 out of 20 there. Okay, pause the video now while you take down the worked example. Notice the difference between the two. On the first one, the probabilities are the same throughout the tree diagram. On the second one, much more difficult, the probabilities change as you move through the diagram. Okay, so 3 questions for you to try here. I've started the tree diagram for you on all 3. For questions 1 and 2, the probabilities are fixed throughout. For question 3, the probabilities change depending on what you took when you took your first counter. Right, have a go at 3 questions. When you're ready, press on pause to go through the solutions. Okay, so for question 1, there's 3 outcomes at which you pass at least one test. You either pass maths and pass English with probability 0.56, pass maths but don't pass English with 0.14, fail maths but pass English with 0.24. Add those together, you get a total of 0.94. That's the probability of you passing at least one test. For question 2, probability of winning at swimming is 3/5. Probability of you losing then is 2/5, 3/8, 5/8, 3/8, 5/8. Probability of losing both events is 2/5 times 5/8. 2 times 5 is 10, 5 times 8 is 40, so it's 10 out of 40. Last question, which really is pushing into higher GCSE territory. You've got 7 out of 10 and 3 out of 10 for counter 1. If your first counter was red, that goes to 6 out of 9 and 3 out of 9. If your first counter was white, it goes to 7 out of 9 and 2 out of 9. Probability of red then is 42 out of 90. Probability of white is 6 out of 90. Adding them together gives you 48 out of 90. Give yourself a mark out of 3, please. If you need any further assistance on that, please take a look at Hegarty tree diagrams. Well done.